What's up, everyone? Welcome back. Patrick here. Moving on to the next question. We have this limit to solve here. Limit as x approaches 2 of the square root of x minus the square root of 6 minus x squared all over x minus 2. Notice if you do a direct substitution, you're going to end up with root 2 minus, over here you'll have 6 minus 4, which would be root 2 as well. So you'll have 0 at the top, and then x minus 2, you'll have 0 at the bottom. So it'll be in that indeterminate form. And so with this limit in particular, what you want to do is you actually want to combine two strategies. The first strategy you're going to use is you're going to rationalize the numerator, and then we're going to factor. So what we're going to do is multiply it by the conjugate, the numerator's conjugate, that is, which would be like that. And then we have to multiply the bottom by it. So notice we kept the two terms on the end the same. We just change that sign in the middle. And then what's going to happen, if I continue it over here, is root x times root x is going to be x, and then we're going to be subtracting root 6 minus x squared times root 6 minus x squared is just 6 minus x squared. You're going to be subtracting that whole term. You got to make sure you put it in brackets. And then the denominator, I'm going to keep these two terms separate, like that. And so what's going to happen here is when we distribute, notice I'll have a minus 6 and then a plus x squared, and then if we rearrange it in a proper quadratic, we'll have x squared plus x minus 6 over x minus 2 root x plus root 6 minus x squared, like that. And then the next line, what you could do is you could factor that numerator, which would factor into x plus 3x minus 2. I'm just going to do it up here to save some room. And then notice that the x minus 2's would cancel out. And now you can plug in that value of 2. So notice 2 plus 3, you'd end up with 5 at the top. Over here, you'd end up with root 2 plus root 2, right? With this, with that term right there. And then notice there's a 1 in front. So root 2 plus root 2, 1 plus 1, that's 2. So we'd have 5 over 2 root 2, like that. Right? Remember, whenever you have a, let's say we have a root c plus b root c, if the square roots are the same, then you just add those coefficients in front, like that. That's what we did from here to here. And then another format this could be in, let's say this was maybe a multiple choice test. This could be an answer right here. Another answer is if you rationalize this, sometimes you won't have any square roots in the denominator. If you were to rationalize it, you'd have 5 root 2 over root 2 times root 2 is 2 times 2 is 4. All right, so 5 root 2 over 4 is the same as 5 over 2 root 2. So either of these answers work. That is the exact value. That is what this limit approaches.